So let's do a question like this. X plus 3 is less than 2, and 2x minus 1 greater than negative 5. Okay, so when we've got two inequalities, we can put either and or in between. So I'm going to do the same question. I put and first, and then I'll do the same question with or to show you what the difference is. So we solve each of these separately. And the other one, 2x greater than minus 5, plus 1. Okay, so we get our two answers. And when they're separate like this, we're going to draw them on a number line and then look. So and, I said at the end of last class, and means where they both have answers, so where the number lines cross, or it's just everything. So it could be this answer or this one, so it's the whole answers together. All right, so we'll make a number line, minus 1 and minus 2. So 0, minus 1, minus 2. Get at least one number on either side of each of your answers. So x is less than minus 1. We put an empty circle because it doesn't have an equal sign, and less goes down. This is x is greater than 2, so it's, or negative 2, so it starts at negative 2 and goes up. So the question is, where are they both? Because it's and, so and is the overlap. So where the pink is and the orange is right in between these two. So that's where both are, because over here is just the pink, not the orange, and over here is just the orange and not the pink, but in between them is overlapped. So what's the solution? How do we write this as a solution? Remember, it's one piece, so you write it as one inequality. You put the lower number first and the larger number second. We always point down towards the smaller, and no equal sign, so that would be the solution. Now, if we had the same question, but we put or in between. So x plus 3 less than 2, or 2x minus 1 greater than minus 5. Okay, so we've got the same question. When you solve them, you get the same two answers. Here we'll get negative 1, less than negative 1, and greater than negative 2. And it's the same number line. But the word or, it doesn't have to be the overlap. It's wherever we draw. So where is drawn on the number line? We've got the number line up here. Or it's just everything. So it would be here and all the way down. So this is included. I don't even need to compare them. And this is included. So now that minus 1, even though it was empty, is now filled in because it's included for this one. So everything on this side, everything on this side, which is what? Everything. So how do we say that? So we say x is an element of real numbers. Or in the other notation, it would be minus infinity to infinity. So either way, but remember I said I'm using this first notation with the inequality signs and not the brackets. Not that you would be marked wrong whichever one you choose, but just in my notes and in questions I do and everything is always going to say x is an element of real numbers. So it just means any number works. Because if we picked, say, 2, 2 is going to work in this one or that one. It will work in one of them. So when you say or, it doesn't matter which one it works in one or the other. Okay? I say in my business course we talk about and or a lot, and I give the example that like or is, if I ask you a question, are you taking chemistry or economics? So would you raise your hand? Who's going to raise their hand? If they're taking chemistry but not economics, would they raise their hand? If I said, are you taking chemistry or economics, raise your hand. So raise your hand. So do it. So who's taking chemistry or economics? Right. So I see hands, but I don't know if you're raising your hand because you're in economics or in chemistry, because it doesn't matter. Or is one or the other. Right? It doesn't have to be both. And if I said, are you taking chemistry and economics, raise your hand. 1. So why did he raise his hand? Well, either he's lying or he's actually taking both chemistry and economics, right? Are you taking both?
Yes.
Yeah. What program are you in? Excellent. Okay. So that's the difference. Or everyone gets to go to the party. Whether you're in that group or that group, everyone gets to go, and you have to be in both groups at the same time. Okay, so that's the difference between the two. Okay, so we're going to mix inequalities and absolute value. Actually, let's start with just an X. Okay, start easy. So absolute value by itself means the distance. And less than 2 means the distance is less than 2. But remember, absolute value, you can go from both sides, the negative side or the positive side, right? If we had the absolute value of X is equal to 2, what are the answers? 2 or negative 2. Either of those will work, because on a number line, from 0, we have 2 numbers that would work. Does that make sense? So that's for this. What would this be with the inequality? What other number would work in here besides, like, well, let's put an equal sign, besides 2 and negative 2? What else would work? 1. Negative 1, 0. Those are all less than 2 away from the origin. So when we say that X is less than or equal to 2, what we're talking about is between so the solution is that any X between negative 2 and 2 will work. Does that make sense? So the distance is less than 2 away. So what would greater be? What would greater? So 2 and negative 2 still work because they're equal. And then greater would be further beyond those, not in between. So it would be 3 would work. 3 is further away, and so is negative 3. Right, here's the distance 1, 2. This is bigger than 2. One, 2, more than 2. Does that make sense? So when we see a greater than sign with an inequality, we're talking about going in the opposite directions. When we see a less than sign in an inequality, we're talking about going in between. So we make the questions harder, of course. So if I had like x plus 1 is less than 3. So this is how I solve it. So I say, okay, less than 3. If that were just normal, I'd put a minus 3 and a 3, and it would be in between. Does that make sense? So the problem is it's not just an x in the bracket like they were up here. So it is an x plus 1 has to be between 3 and minus 3. So step 1, draw a little sketch to show if it's in between or outside. Step 2 is to write it as being in between minus 3 and 3. Now, we didn't solve any like this with two inequalities in it because you can't. You have to separate it, solve them separately like we were just doing, two equations, and then you put it back together. So step 3 of solving something like this would be to write the two equations. So what did I do here? I took the x plus 1 and I said it has to be, minus 3 has to be less than that. And then I took the x plus 1 and put it with the 3. So I broke it up, but you put the middle part with both. And an and, because it was and is in between. Now you solve each of these separately. So this is step 3. So minus x, remember the x goes on the left. Now what happens here? I have to switch the sign because I have to divide by negative, because the x on the left was negative. So that will be x greater than negative 4. So you'll always have this scenario when you're doing it because your x, well, one of the two will have an x as negative in these types. So you have to remember to switch it. It's going to be easy to check because when you go to draw your number line, if they don't go in opposite directions of each other, then you'll know you messed up. If they don't go in between like this, then you'll know you messed up. Okay? So you'll know, oh, I must have forgot to switch my sign somewhere. Or you solved it wrong. So this one. Okay, so we've got our two answers. Solve each of them with step 4. Step 5 is to draw the number line with them on it. So 2. So greater than 4. Now this is not shaded in because there's no equal sign, and that would go in this direction. And here is less than 2. Goes in that direction. So is it in between two numbers? Yes, so you didn't mess up. Okay? If it starts that it's in between, then it should end that it's in between. So we just shade this in, leaving those circles empty on the ends because there's no equal signs. And we would say our solution is that x is between negative 4 and 2. These arrows, of course, don't mean anything. Okay, so step 5, draw your number line and answer. Yep. Because there's no equal sign. So it's not equal to 3, or it's not equal to 2. It starts like 1.9 counts, so yeah. Does that make sense? Yeah, the line under means equal. Yeah. And there's none here. Up here I had it, so I colored them in because they were equal. Okay. Okay, so what was step 1 up here? Just a sketch. It's not going to be the right answers, but it's going to use whatever number I gave you here. So this is saying, so here's -3 and 3. This is saying that it has to be bigger. So that's like the 4 and the -4, so bigger. This time equal, so it's going to go in this direction and this direction. So that's not your answer, but it's going to look like your answer with different numbers under. Okay, so it's sort of a check in the beginning. It makes you write the right thing, and it ensures that your answer looks like that in the end. Up here, it was between 3 and -3. And this just, your answer looks like that, but between the two correct numbers. So when you start, if it's going in the opposite directions, it should end like that as well. Okay, so now we set it up. So this would be like x is less than -3, and this is like x is greater than 3, but we don't have an x. So we have 2x minus 1 is less than -3, or, why or? So greater than is that way, less than is that way, or because they don't overlap, it's in one or the other. Then you solve each of them separately. So the first one, x is less than -1. And x is greater than 2. What would happen if you plug -1 in here? What would you get, do you think? -3. So that's like the -3. When you plug 2 in here, you get +3. So those are the equivalent. Okay, so we put them on a number line. So greater than or equal to 2, so color it in. Less than or equal to -1. And when they're two separate, you have to list them separate. With or, because they don't overlap. And that would be your answer. Oh, I keep putting 3. Let's put 8. Okay, questions? Okay, so this. Yeah?
Why did you flip the sign that after the first step to the second step?
Here and here?
Yeah.
Well, one of them is this piece, which is less than -3, less than -3. And the other one is this piece over here, which is bigger than 3. So we make one less than -3, and the same thing greater than 3. So it gives us those two pieces. Does that make sense? So I didn't flip the sign, I just wrote what the two pieces would be.
Okay.
Yeah.
Do you want me to use chalkboard?
What's that?
I have to go.
Oh,
Do you
yeah.
want to rather than use the back door?
Oh, it doesn't matter. Yeah, you can go up there. There's 2 doors if you go that way. Okay, so let's try this one. So step one, draw a little number line with 8 and -8 in it. So -8 and 8, because it's an absolute value, so we get those two answers. So then what? Is it going to be in between those two or outside of those two? Outside. What sign is that? That's a greater than 8, right? So greater than 8 would be outside, so it would be this way and that way. So this is less than -8, and this is greater than +8. So we set up our two equations. So the first equation, 1 minus x is less than -8, or 1 minus x is greater than 8. No equal signs, so we're going to have empty circles in the end. And our answer, again, should look like this, but with different numbers, not the 8 and -8. So less than and greater than. Yep.
I don't understand when you're getting the less than -8.
So if you want a distance bigger than 8 away from 0, so in this direction, this would be 8 when you get to there, and then more than 8 away is down here. That's more than 8 away. So on the number line, where is that? That's all the numbers that are less than -8. -9, -10, -11, those are all a distance bigger than 8 away from 0. So on the number line, that is less than -8. Doesn't mean the distance is less. It's the numbers are bigger as you go down, so it's sort of opposite, right? Because -9 is 9 away from 0. -10 is 10 away from 0. So those ones are the bigger ones. But it's on the number line itself, it's less than -8, are the numbers you want. So less than -8. So minus x less than -8 minus 1. Bringing that 1, there's a plus in front of it, even though you don't see it. So when you bring it to the other side, it becomes minus. Dividing by a negative flips that sign. So x is greater than, minus 9 divided by minus 1. 9. So greater than 9. The other side. Eight minus 1 is 7. Again, divide both sides by negative. That switches the sign. Okay, so we've got our two pieces. When we draw them, they should go in the opposite directions. So we've got a 9 and a -7. So greater than 9, but not equal. So empty circle, and greater than 9 is up here. And less than 7 is down here. So our solution is that x is less than -7 or x is greater than 9. It doesn't matter what order you list them in, but it's standard to put the smaller one first, okay, or left to right. When we answered them, because we had to flip the signs in this particular one, that was because there was a minus in front of the x to start, they end up in the backwards order, but it's still. If you forgot to flip the signs, they would be pointing into the center, and that would be wrong, because you knew they were supposed to point outwards. Okay? All right, so another one that's less than. Okay, so what's step one? Draw the number line with 1 and -1 on it to see how to rewrite this. So -1 and 1. Now, do we want in between those two numbers or on the outside? It says less than 1.
In between?
In between. 'Cause less than 1 is, here's 1 or less, is smaller. So all of these, no equal sign. So when we finish our answer, it should be in between two numbers. So how do we write this? Remember, this is that x is in between 1 and minus 1, like that. So we would write this, 2x minus 3 over 4 is between 1 and minus 1. Now, you don't solve it when it's got two equations. We split it up. We put that middle part with the negative 1. We put that middle part with the positive 1. Or and. Oops, I don't know what I just did. So we take this. Okay, so the whole middle with each of the signs. And it's and, because it's in between. So how do we solve this? Someone said it earlier. Yeah. So the 4 minus 1 times 4 is minus 4. And then solve it. So we'll move the 2x over. And the 4. I'm dividing by a negative, so I have to switch that sign. And you just have to remember that. You have to remember to switch the sign. There's no other way to do it. So as soon as you start dividing by negative, you have to switch that sign. Okay, so this one, same idea. Cross multiply. 1 times 4 is 4. And then put them on a number line and make sure that they're in between the two numbers when you draw it. So minus a half is smaller than 7 over 2. So greater than negative 2. That way. Less than, so they are going in between. So our solution is in between. Questions? Okay, let's do another one with a fraction so we can practice fractions. Okay, so greater than 3. So first draw your number line with your minus 3 and your 3. Greater than is past those numbers. So this one is x is less than negative 3, and this is x is greater than 3. So instead of x, we have whatever's in that bracket. So you'd rewrite it first less than negative 3. So 2x minus 3 over x plus 1 less than negative 3. And the other is or, because they don't overlap, the same thing but greater than 3. So, how do we solve? Cross multiply again. It doesn't matter. The last one just had a number on the bottom. You could have x's. So when we have x's on the bottom, we have to multiply that negative 3 by x plus 1, that whole thing. So make sure you put in a bracket, or make sure you multiply it by both. This one will end up doing the same thing. 2x minus 3 is greater than 3 onto x plus 1. So the whole bottom times the 3. Minus 3x minus 3. So move the x's to the left. Ooh. Cool. So what does this give us? 5x is less than 0. Divide by 5, that's okay. 0 is an answer. So x is less than 0. It's just the same as any other number on the number line. Okay, we'll solve the other side. Three times x and 3 times 1. Two x minus 3x is minus x. Divide by a negative, that's right. So x is, switch that sign, less than minus 6. Okay, so minus 6 is smaller than 0, so they would go in that order. Less than 6 is this way. Greater than, cool. Less than 0. I might have found an exception to my rule. I'll think about this in a second. So, I had been saying that they go in opposite directions. Now, I did put a fraction, so maybe something different happened. We'll check our answer to see if I either made a mistake or if, in fact, it does go both in the same direction. So what if it does go this way? What would we answer? Yeah, we would answer x is less than 0. Why? It's or, so remember, everyone gets to go to the party. So everyone in both of these are included. So what would be both? It doesn't have to be the overlap. It can be anyone. So the answer to this would be, the solution would be that x is less than 0. So let's test it out. Yep.
Would you have to specify the x if you made it 6?
No, it can be, which is a good question. But it can be negative 6. Why? Because negative 6 is less than 0. It's included in this one. And remember, everyone gets to go, whether they're the negative 6 or not. Right? As long as they're less than 0, they get to go. So this part really didn't give us any information. And I'm guessing that it's probably right. I don't think I did anything wrong, but I'm not saying for sure. It's probably right, and it's probably because of the fraction made it work different. So how would we test that to see if that's actually true? instead of going beyond these two numbers? How could we test it? Whenever you want to check something, you try, right? So we plug a number in. So what would be a number in here that we might want to check? Something in here maybe? Because if that was supposed to go that way, then these numbers wouldn't work, but let's see if they do. So let's check -5, -4. -6 would be fine, but that would be trickier because that's here. Let's go -1. So what are we checking it in?
The
Original before you change anything, because maybe you changed it wrong. So we write down our original equation, just as it is, take out the x's, and in their place put the -1. So 2 times -1 is -2. Oh. Bad. I'm glad I checked -1. So this question's getting more complicated by the second. So what does this mean?
Don't you have to like set restrictions to say that X can't, the bottom can never equal 0, so yeah, it's have to be greater than.
Yeah, so she's asking is maybe we had to set restrictions because it was a fraction with an x on the bottom? So what would the restrictions be? Can't be -1. Could it not be any other number? What makes the bottom 0? -1. We just found it, right? So yeah, so it can't be -1. So that's true. Well, let's check another number. What happens when we plug -2 in? That's not going to make the bottom 0. What's it going to do? So -4 minus 3 over -2 plus 1. -7 over -1. What's -7 divided by -1? 7. And what's the absolute value of 7? It's also 7. And we wanted to know if it was greater than 3. Is that greater than 3? Okay, so that worked. The -1 didn't. This one worked. What about a number over here? What could we plug in to check this region? 1. Let's check 1. Okay, so instead of the x, we're going to put in 1. So what do we get here? 2 minus 3 over 1 plus 1. -1 over 2. What's the answer to that? Absolute value of -1/2 is 1/2. So is 1/2 greater than 3? No. Okay. So, no. Yeah, we only say admissible when it's a square root or a log. Okay? So, no solution otherwise. But this is not that there's no solution. So what did we just test? So we tested, so we had a 0 on the number line. We tested 1 and that didn't work. And -1 also didn't work. Put an empty circle, anything that doesn't work. Empty circle on the 0 because that. And what we had otherwise was this. There was a -6 that was in question. What if we put that in? So what if we were to check negative 6? What do we get? Negative 6 times 2, minus 12. Minus 15. Over 5. 3, it's 2 negatives. Positive. Now, this one's tricky. What was the, oh, greater than 3. So is that greater than 3? No. Because there's no line. Otherwise it would have worked, right? If we had made that an equals, it would have worked. Otherwise it didn't. Okay, so is there any other tricky numbers that might or might not work? So let's, on this number line, let's say why they don't work. Okay, so why does the 0 not work? We didn't plug it in, but what would you get if you plugged it in? No. You would get negative 3. Okay, so, and it's not bigger than 3, it's equal to 3. Okay, so it didn't work because it's equal to 3 and we wanted only bigger. And it's equal, not greater. Okay, so that's why the 0 doesn't work. Why does the negative 1 not work? Right, it's undefined. That is that we get a number divided by 0 when we plug that in because the fraction started with x's in the bottom. And what about the minus 6? Right, this one gave us equal to 3, which is not bigger than 3. It's equal to 3, not greater. Okay, so how would we write the solution to something like this? So we have a hole at 0, we have a hole at negative 1, and we have a hole at negative 6. These numbers will work. You could test in between if you wanted to, but trust me, they all work. So how would we write this? So how do we say that x is not equal to something? Yeah, you just put a line through the equals. Yeah. Negative 7 doesn't work? Oh, shoot. And I said trust me, but I'm glad you didn't. Okay, so, okay, we have time. So if we plugged in negative 7, this question's getting worse and worse, isn't it? Actually, okay, so would this be on the test? Actually, it could be, but not this next test because we're doing this in fractions part 2. Yeah, so I told you, fractions, we're doing everything easy, but we're actually leading into this, so it's actually okay. Yeah. Probably not this complicated, but okay, not this complicated, more complicated than this, actually, because you're going to have to factor things, but there is a different way to test all of them quicker. Yeah. So there's a better way to test them than what we're doing now, but I just haven't shown you that yet, so I'm doing it the long way by just plugging in numbers. So, yeah, if we plug this in, (17/6). Without a calculator, how many times does 6 go into 17? 2, so it's 2 point something. So is that bigger than 3? No, so that doesn't work either. Okay, so assuming this is our answer, how would we write it?
Would you say the not equals to first before the equals?
I usually just write them after. So you ignore anything that's not equal at first. So you could say that it's between -6 and 0. And then a comma and anything you don't want to include that's in that. So you would say -6, like that. And then a comma, or you could say and. But I usually just do a comma. X is not equal to, not equal to -1. So take the biggest, because right now, by not putting the equal signs, I'm saying don't include 0 and -6, right? By not putting the equal signs, I'm saying that. And in between that region, there is one number that doesn't work. Okay. So let's conclude this, just a note at the bottom. Not when we have fractions. It's not fractions that is an exception. It's what? Any ideas? That last one we did was a fraction and it was okay. But what was the difference between that? Right. So this was a fraction and it was okay. This had no problems in it. When does it become something different? Yeah, when there is a rational function, that means fraction, with x's in the denominator. No, because none of them under will work. We're just running out of time. No, this is x is bigger than 6. Yeah. Okay. So I actually didn't mean to do this today, but it's okay because we will go back to these, because when we solve fractions later, we have to look at where the domain is, which means what values don't work, and we have to take those out of any solution. So we are seeing this again. You don't need it for this particular assignment, but you will need it after.